Hello everyone and welcome to the second episode of Rory Explain. This one's all about vectors. This time we're going to jump straight in. So what is a vector? Well, a vector is just another fancy physics word for a quantity having direction as well as magnitude. The most basic vectors only have one direction, like left, and one magnitude, like 2. Vectors are commonly represented as arrows, with 2 vectors of length 1 to the left being the same as one vector of length 2 to the left. Typically, people use plus and minus instead of left or right to describe vector directions, because it makes them feel more clever. This means that it's very easy to add vectors together. All you need is a starting point, or origin, and another point to keep track of where you've got up to. To start with, the origin and the track point are in the same place. Then, one by one, you put the vectors with their tails on the track point, and move the track point along until it's at the tip of the vector. Then you repeat the process. Once all the vectors have been used, the answer to the sum is the vector which takes you from the origin to where the track point finished. In this case, that's plus 1. To describe more complex position using vectors, you need to use more dimensions. Any new dimension has to be orthogonal to the existing dimensions of the vector. That means that changing its value in the new dimension doesn't have any effect on its value in any of the other dimensions. This means that your dimensions have to be at 90 degrees to each other, like this or this, but not this one. By now, you should be able to understand the force polygon from my episode on forces. Each force is represented by a vector. When we add them together, we find that the track point goes back to where it started, meaning that the resultant force, in all the dimensions, is 0. An example of this in 3 dimensions can be found in the columns of Barcelona's Sagrada Familia. Look how the columns split halfway up. This means that forces are applied in lots of different directions, but because they balance, the structure stays standing.